Next one is removing node from the given position in the linked list. Now in this function you have to apply some logic. So suppose this is the linked list with nodes 1 2 3 4 5. 5 nodes are there and head is pointing to the first node. So what I am doing in this function, I have declared two pointers, trav pointer and follow pointer. So that logic will be same. We have seen that follow logic where follow pointer will follow the trav pointer in remove from end function. So similar type of logic I will implement here also. So I have declared two pointers, one is trav pointer, other is follow pointer. So trav will allocate memory 4 bytes, follow will allocate memory 4 bytes. Now trav is equals to head, that means this 1000 is here and it is pointing to the first node. Follow equals to trav means this is also pointing to the first node. After that, now what I will do, first I suppose I want to delete a node which is at 4th position, that means 1 2 3 4. I want to delete this node with value 40. So if I want to delete this node, what I will need one pointer which will point to this node and one more pointer which will point to the node before that node, so that I can disconnect this link and I can bypass that particular node which I want to delete. So that thing I can do. So I will need two pointers, one pointer which will point to the node to be deleted and another pointer which will point to the node which is before that. So those two pointers are nothing but the trav pointer and follow pointer. So what I will do, I will write some code where after which trav pointer will start pointing to the node to be deleted and follow pointer will start pointing to the node which is before that. So now to make that trav pointer to point to this 40 node, how many jumps I need to perform? Now it is pointing to the first node, so after one jump it will come to the second node, after second jump third node, and after third jump it will come to the fourth node. That means if position is 4, number of jumps will be 3 for this trav pointer. In general, if position is POS, then number of jumps will be POS minus 1. If position is 5, then I have to perform 4 jumps, so that trav pointer will come here 1 2 3 4. So in general, I need to perform position minus 1 number of jumps. That means I will write some loop here which will iterate position minus 1 number of times. So it will be something like this: POS greater than 1 and POS minus minus. That means suppose position value is 4, then 4 is greater than 1 first iteration, then POS minus minus, POS will become 3, 3 greater than 1, condition is true, second iteration, POS will become 2, 2 greater than 1, third iteration, POS will become 1, 1 greater than 1, this condition will be false. That means it will iterate 3 number of times. So when position is 4, this loop will iterate 3 number of times, and during those iterations what I will do, I will move that trav pointer to the next node and follow pointer will point to the previous node of trav pointer. So that logic I know how to write. I will say follow equals to trav first, and then I will write trav equals to trav arrow get next. So when I do this, what will happen? So follow equals to trav, it is already both of them, trav and follow, both are pointing to the first node. After that, trav equals to trav arrow get next. That means trav is 1000, trav arrow get next is 2000. So this 2000 is assigned to the trav. So after the first iteration, trav will point to the second node and follow will point to the first node. In the next iteration, follow equals to trav. That means now follow equals to trav. So this 2000 value is assigned to follow. So follow will point to the second node. And trav equals to trav arrow get next. It will take this trav pointer to the next node. In the next iteration, which is third iteration, again follow equals to trav. So trav here is 3000. Now when I say follow equals to trav in the third iteration, follow will also become 3000. So it will start pointing to this node, and trav equals to trav arrow get next will take that trav pointer to fourth node. So when all the iterations are over, this will be the picture. Trav is pointing to the node to be deleted and follow is pointing to the node which is before that node which I want to delete. So after that, what I will do, I want to first store the address 5000 here at this location. So this location means it is follow arrow. I want to update this, so it is follow arrow set next. To which value I want to set it? 5000. So 5000 value is stored here. So it is trav arrow get next. So basically I will write here follow arrow set next. inside bracket trav arrow get next. So when I write this thing, trav arrow get next is 5000. It is, I mean, follow arrow set next is set to that value. So this 4000 earlier value, which was 4000 here, is now written with overwritten with 5000 value. So now this pointer is not pointing to this node, but it is pointing to the next node. So I have bypassed the node to be deleted, and after that I will say delete trav. So when I say delete trav, this node is deleted, which is pointed by trav. When the function is over, all local pointers will be removed from the stack. So this trav and follow, they are destroyed. That means there won't be any pointers here. This is pointing to the next node, and this memory is also freed. That means this will be the new linked list after deleting node at given position. So let's implement this one. So let's write the definition for remove from position, remove from POS. It is taking one integer argument, which is position of the element to be deleted. So I will write the definition here. Return type is void, class name is linked list, scope solution, name of the function is remove from POS, and it is taking int POS as argument, which is position of the element to be deleted. Now here also I take two pointers, one is trav pointer and other is follow pointer. So trav pointer will be pointing to head and follow pointer will point to trav. That means all of them are pointing to the first node. Now what I will do, I will iterate the linked list so that trav pointer will point to the node to be deleted and follow pointer will point to the previous node of that. So for that we have seen while loop will be there. I will make the trav pointer jump position minus 1 number of times. So till position is greater than 1, I will write while loop, and I will say POS minus minus inside the definition of while loop, so that it will iterate position number of 2 number of times. So during those iterations, trav pointer will go to the next node. So trav equals to trav arrow get next, and follow pointer will follow the trav pointer. So follow equals to trav. So when the while loop is over, trav pointer is pointing to the node to be deleted and follow pointer is pointing to the node which is before the node to be deleted. So now first what I need to do, I will write follow arrow set next trav arrow get next. So I am bypassing the node which is to be deleted, and then I will say delete trav. So now let's check in the main function. Suppose linked list is 10 20 30 40 50 and I remove from POS. I want to remove the node which is say 4th position node. That means 40 value I want to delete. So I will compile this and I will run this. So 40 value is removed. So remove from position is working, but now here I need to also handle the corner cases. For that I have not written the code. So suppose I give the position which is invalid, then it will give segmentation fault. Yes, because that position is invalid. So for those corner cases, again you have to add some code in this definition. This is the basic logic or the core logic for remove from the position, but to handle the corner cases I have to do something extra. So what I will do here, if position I will write these conditions. Suppose position is 1, so first corner case is position is 1. That means I want to delete the first node. Then I already have some other function which is remove from begin. So that function I will call. So I will call here remove from begin. Then if position is greater than equals to the number of nodes. Now earlier I have already implemented one function here in this linked list class, which is get count. Now this get count function is giving me the number of nodes, number of existing nodes into the linked list. So if the position is exceeding the value of number of nodes, then I will throw some exception, or I will print some message to the user. So that thing I will do. So here, if position is greater than, or rather say if position equals to get count is the name of the function. That means if it equals to the number of nodes, then I will remove the last node. so remove from end, so these two corner cases will be there. And if the position is greater than get count, so again else if POS is greater than get count, that means it is exceeding that number of nodes, then what I will do, I'll print some message invalid position. And I will return from the function. So here I will write the return statement. So return, no need to execute the further code. And the logic for deletion, which is the logic for some generic node in between, that logic I will write into the else part. So I think this will be the complete code. Now let me check. Suppose in the main function I give the position as 5, then this should delete the last node. Say position is 5, I will compile and I will run. So last node is deleted. If the position is 1, then it should delete the first node. So first node is deleted, so that is working. And if the position is 10, that means number of nodes are not there, then it should print the message invalid position and nothing is deleted. So this is also correct. So this will be the complete definition for delete from position. So this was about all the operations in single linked list. Thanks for watching the video and please do subscribe.